All right, good folks, today is Friday, and we're going to start off in our interactive notebook today, page 20. Yes. I turned in the quiz from last week and I missed. That's fine. Not yet. I haven't checked it yet. I'll check it on today. All right, here we go. We did this one on yesterday. I don't know why it keeps going in and out the screen. All right, so we're gonna do some justifying steps here for the equation that we solved. We're on page 20. Please make sure that you open up your interactive notebook to page 20. Okay?
What's the headache or whatever it's called?
I'm getting there. In the corner, Q1, the page number is 20. And we are doing justifying steps. I don't know why it's doing that. I probably have to start again. The screen is going in and out. I might have to start it again. And it is justifying steps. We are justifying steps. Using algebraic properties. Super important that you understand and know what the properties are so that as you're solving an equation, you can tell what property is illustrated as you solve. Okay, so we're going to do some examples. We've already talked about what the different properties are, and now we're going to do some examples. Okay, all right, let's do this problem. We have 12b. Oops. Plus 9 is equal to 12b plus 11. Okay. All right. So this first line right here is given. Okay. For each and every single step that we do, we're going to give a reason for the step that we take. Okay. All right. The first thing, we don't have distributive property here, so we skip that first step. The second is to combine like terms on each side separately. We cannot combine these two terms on this side, nor can we combine what's on the opposite side, okay? Now we're going to move the variables to the same side. It doesn't matter which one we move, because if you hadn't noticed, they're exactly the same, which is a key indication that our variables are going to cancel out, so that means it's either going to be infinitely many or no solution here. So I'm going to move this 12b. This is a positive 12b, so in order to move it, I'm going to subtract 12b from both sides. When I subtract the same number or term on each side, what property is that? Does anybody remember? I'm subtracting, so it's the subtraction property of equality. If you were to add the same number or term to both sides, that's the addition property of equality. If you multiply the same number or term on each side, it's the multiplication property of equality. Whatever operation you use on both sides, there is a property of equality for it. Okay? Because you're doing it on both sides of the equal sign. Here, this is 0, and I'm left with 9 is equal to, okay, this is 0, and I'm left with this is equal to 11. Is this sentence true?
No.
This is false here. This is false. Since it's false and the variables cancel out, this is a no solution. This is a no solution. That will be the answer to this. No solution. The variables cancel out, and this sentence is false. It's a no solution. If this mathematical sentence was true, it would be infinitely many solution. That means that every number that we plug in for the variable is going to work. But there is absolutely no number that we can plug in for B that's going to make both sides of this equation true. So this is definitely no solution. Any questions about how I justified and how I solved this equation? All right. Anyone still copying? Let's move on to the second one. We have 4 parentheses x plus 9 is equal to x plus 9. Okay? Again, we're justifying each step. Okay? We're justifying each step. This first line is the problem. It is given. It is given. In solving this equation, what's the first thing that we're going to do here? Yes. Distributive property. Very good. We're going to do distributive property here. When we distribute, well, that means we're going to multiply 4 times both or all numbers in the parentheses. What's 4 times x? 4. This is 4x. What's 4 times a positive 9?
36.
Very good. A positive 36. Again, this is distributive property. Any questions so far? Okay. After distributive property, what is the next thing that I'm going to do in order to solve for x? What's my next step? Anybody know? Yes, baby. Move the variables to the same side. Okay, let's decide. Which would we like to move, the 4x or the 1x? 1x, okay. I would probably move the 1x as well because it's smaller. How would I move a positive 1x to the other side? I would subtract 1x from both sides. I'm subtracting the same number or term on both sides. What property would I call that? Very good. Subtraction property of equality. Okay. This is subtraction property of equality. So this is going to give me, when I subtract, on this side, I get 3x plus 36. And on this side, I'm left with 9 because this is 0, right? 1x minus 1x is 0. Okay. Now what am I going to do in order to solve for x here? Somebody different. You want to try?
You subtract 36.
Mm-hmm. You're just going to subtract 36 on both sides. Very good, babe. Okay. When I subtract 36 on both sides, what property is this? Subtraction property of equality. When I subtract here, this is gone, and I'm left with negative 27 on this side. What about the opposite side? 3x. Okay, because this is 0. Okay. What's going to be my next step? Yes.
You divide
I'm going to divide. What am I going to divide by?
3.
I'm going to divide by 3 on both sides. What property is this that I divide 3 on both sides? Yes.
Division property of equality.
Division property of equality. Okay. So when I divide by 3 on both sides, this is going to give me x on this side is equal to what number? -9. Okay. The answer here is what? What? X is equal to -9. What would be the name of this property? Anybody know? I could say x is equal to -9, or I could say -9 is equal to x. Does that help? Symmetric property. I always spell that wrong.
Oh, yeah.
It's 2 M's instead of 1.
It is.
It is?
Symmetric, yeah. 2 M's. Y'all not know this?
I get that
Yes.
wrong too. Sometimes I put 1, sometimes I end up putting 2. I always have to double check to make sure I spell that word right. Okay. Questions about that? Okay. I'm probably not gonna have enough space to put another problem down this way, because look at how much space I've taken up here. So I'm gonna move to the next page. Anybody still writing this before I move to the next page? Okay, I'll pause for the call. All right, let's do number 3. The third one. Please make sure you use the front and back sides of pages, okay? All right, so let's do the, wait a minute, let me make sure I didn't do that one. Yeah. Let's do this one. We have 5 parentheses 5t plus 1 is equal to 25t minus 7. This, of course, is a given. This is the problem. It's given. Okay. All right. So first thing that we want to do here is what? What are we going to do? Distributive property. We're going to multiply 5 times both numbers in the parentheses. And what does that give me? Yes.
I was asking, what is the variable?
T?
It's T.
This is T. Yes. So when we distribute, what's 5 times 25t? Oh, dang. 5 times. I said it in the answer. I'm sorry. And this is going to give me 5. All right. Already, this is starting to look familiar. It should. Okay. We notice that, look at this. Already looking at this, is it possible that these could be equal to each other? 25t, whatever t is, plus 5 is equal to 25t minus 7. Is that even possible?
No.
It's not. It's not. But let's prove that it's not possible by continuing. Okay. What are we going to do? We did distributive property. Forgot to write that here. Okay. So what are we going to do next? Yes. Go ahead, baby.
Subtracting 5.
Very good. Subtract 25t from both sides. Good job. Okay, when we subtract 25t from both sides, what property is that called?
Subtraction property.
Subtraction property of equality. Okay. So when I subtract, this is gone and this is gone. And so I'm left with 5 on this side and I'm left with -7 on this side. Is this mathematical sentence true?
No.
It is not true. This is not equal to each other. Put a line through it. This is false. So what is my answer for a problem that has false? Yes, it's no solution. If it was true, that would be infinitely many solutions. Number 4. Let's do 16 parentheses 4 minus 3m is equal to 96 parentheses. We have negative m over 2 plus 1. This is a given. This is the problem that's given. Yes, baby.
Does that say 96?
It does. Yes, let me make it clear. Okay. All right. What's going to be our first step? Somebody different, same people still responding. Yes, distributive property. So we have distributive property on both sides. All right, so let's distribute. We have 16 times 4. What's 16 times 4?
64.
Okay, we got 64. Then we got 16 times a negative 3. That's going to be what? A negative what? 36. 36 what? Oops. Okay, now we're going to multiply this. When we multiply this, we write this as a fraction because look, this is a fraction also. So this is going to be 96 on the top, negative 96 on the top, and 2 on the bottom. Let's write this out to the side so we don't have as many steps, okay? So if I do that out to the side, I'll erase it. 96 on the top, negative 96 divided by a positive 2. What does that give me? Yes.
It gives you 48.
Okay. Positive or negative?
Negative.
So when we divide by 2, how many times will 2 go into? 2 goes into 9.
4 times.
We got 4 times, and this gives us 8, because some people are like, what in the world are you doing, Miss Reyes? All right. And then how many times will 2? Do y'all see it now?
Yeah.
Okay. So we got negative. Somebody said, what you doing, Miss Reyes? All right. Yes, baby.
How'd you get 36
What did we do?
Shouldn't it be 48?
6. Let's multiply. Sorry. Let's do it out to the side. So what's 3 times 6?
18.
And that gives you what?
40.
48. I don't know how we got 36, y'all.
Good job,
Y'all stop teasing and calling that boy's name. Y'all don't want me to say it. I think you like him. All right. So now let's distribute 96 times 1. What's 96 times 1?
96.
What? Oh, boy. All right. So look, we're already starting to notice something. Look. What do we notice? How do we know it's going to be no solution? Okay.
They'll cancel out.
Okay, the variables are going to cancel out. All right, what property? What do we use here? Distributive property. Let's write that first. Sorry, y'all. My bad. All right, so we did distributive property here. So now what are we going to do to both sides? Ooh. Add. How do we know to add 48?
Because it's already subtracted.
Very good. So we're doing the inverse to move it. The variable's now going to cancel out, and we're left with what on this side? Positive 64. And what are we left on this side? Sorry, y'all. Positive 96. Is this a true sentence?
No.
No, it's not. And so what's my answer here?
No solution.
No solution. This is my answer. Put a line through the equal sign. That's what? What does that mean? Not equal. Not equal. Yeah, baby.
You didn't put the other steps.
I didn't put. Oh. We forgot to put this one. What property is that? Sorry. Thank you, babe. This is addition property of equality. Thank you, sweetheart.
Is it okay if we like abbreviate it?
As long as do you know what it means?
I'm putting like the
Just put addition, and then you want to put P, property, abbreviate of equality. Sometimes they'll put the equal sign for equality. What I don't want is that you start abbreviating and then you look for the right answer and you don't remember what it is. Yes, babe. Wait till after this part is over. Okay. All right. So let's do this. Now for this one, let's go through all of the steps, and then I want you to identify what the property is. So we're gonna completely solve it, and then I want you to go back and identify what property we did. Okay. All right. So this is number 5. Let's do 6y minus 8 is equal to 2 parentheses 3y minus 4. Okay, so here we are going to distribute, right? So this is 6y minus 8. 2 times 3y gives us what? 6y. 2 times a negative 4 gives us what?
-8.
Good job. Okay, so now here, look, we can tell already both sides are exactly the same.
Yes.
Okay, they're exactly the same. Okay, so this is going to be infinitely many solution because, again, the variables are going to cancel out, but the math sentence is going to be true. So instead of it being no solution, since it's a true math sentence, it's going to be infinitely many solution. So let's go ahead and prove it. So with both sides, we're going to subtract the y on both sides. Sorry, 6y. This is gone, so we are left with -8 is equal to a -8. Okay? This is true. So that makes this infinitely many solutions. That means every single number that we substitute for y is going to work. This is infinitely many solutions.
Can you just put the infinity symbol?
No, just write infinitely many. What's the infinity symbol though? This.
Sideways 8.
Mm-hmm. But please make sure that you write the word, because that's what you're going to see. Yes, baby.
You forgot to write the things on the side.
I didn't forget. You're going to write them. Okay, so now I want you to take the time to write the properties illustrated in each of the steps. Okay, let's do that now. I'm going to pause for the calls, give you a chance to think about it, and see if you got it right. Get it right. All right, here we go. What did you write for this first line here? Yes. For the first line. Given. All right, so what was the first step? It's distributive property. We did distributive property as our first step. Okay. What did we do Next, yes.
Subtraction property of equality.
Subtraction property of equality. Okay. What did we do after that? What property does this right here? What property does this illustrate here? Yes. Hmm, that's like really, really close though. Oh my God. It's not that it's wrong, but it's not two different. It's not like X is equal to this, then this is equal to X. That's more symmetric. I don't even know if you guys wrote this one down, but it starts with an R.
Oh.
E.
Distributive? With the reflexive?
Reflexive property.
Yeah. That's what.
Why would you think I would say this is more reflexive property? Yes. Because because it's the same number. Because it's the same number. Does that make sense? Cameron, does that make sense? Okay. Any questions about justifying steps here? Does anybody still feel like, oh, this is a little difficult? You're using almost the same ones that you can see. The properties of equality, when you're working on equations, you know you're going to use that one a lot. Symmetrical, you'll use that one often. Reflexive, like you see here, you use that especially when you get to these. And of course, distributive property. Those are the ones you use most often. Questions, comments, or concerns? If you're combining like terms, then that's what you say. Combining like terms. It's not a property, but it's a reason. So you can use combining like terms as a reason to justify that step. Anybody lost? At this time, I need you to take out your packet so that you can answer your questions, and we're going to submit our work at this time, okay? You can go ahead and put this away, okay? Take out your packet and answer your essential questions at this time. Yes, sir. I'm going to show you where to put your answers for your essential questions. Everything is going to be on Canvas. Yes, babe. The essential questions, when I get to the part where everybody's submitting, then I'll check your cards, okay?
But I need the help submitting.
I'm going to show you now. All right, I'm going to pause my video so I can show you how to submit, okay?